Welcome to this week's Space Startup News Roundup. It's a curated list of space news I found around the internet, mostly on the X platform and space news websites. We have a new X account. It's at Space Startup Hub. Space Startup News handle was taken already, and it's longer than 15 characters, which is the most you can have on X for new accounts. So at Space Startup Hub, and I'll put it in the video descriptions going forward. Oh, before we start, I'll put the chapter markers in the video so you can skip stories you're not interested in. Okay, let's get on to the news this week. The first story I want to cover is, put myself in the corner, the Griffin moon lander has been delayed until 2026. So this is Astrobotic's Griffin lunar lander, and this will be the second launch, second mission. The first mission in 2024 did not succeed. There was a propellant leak and it ended up plunging back into the Pacific Ocean. So they're going to launch their second mission. It was supposed to be this year, but now it's been delayed until July 2026. It's carrying NASA and commercial payloads that include rovers from Astrolab, the Flip rover, and also from Astrobotic. That is the company that's building the lunar lander. They have their own little rover. Astrolab's rover is called Flip, and that stands for Flex Lunar Innovation Platform Rover. And Astrobotic have the Cube rover. And there's also some other smaller payloads on the moon lander. In terms of the lunar lander, the critical components like thrusters, pressure tanks, and solar panels and payload ramps have already been successfully fitted to the vehicle. So we can get rid of that now. So it's making progress, but it's not going to be in a position to launch this year. So it'll be mid-2026, and that will be on a Falcon Heavy rocket. If you're not familiar with what it looks like, here is the Flip rover. You can see the wheels, which will be on the larger rover, testing out the wheels and the rover on the moon's surface. And then we'll see the bigger version called the Flex rover, which will have the same kind of wheels but can carry astronauts. So they also have an X post where they're talking about the wheels. They're saying it's highest traction space tire ever created, and they're working with Venturi on the hyper-deformable lunar wheels. They've done extensive testing at NASA's Glenn Research Center and the Johnson Space Center. So they've been able to verify it can withstand the temperatures on the lunar surface. During the night, it's minus 240 degrees. During the day, it's 130 degrees. That it can handle the rugged surface, the abrasive moon dust. It could travel over boulders because the wheels deform. It can handle slopes of 26 degrees. So now they've finished the testing. The tires are now attached to the Flip rover, and we're headed to the lunar South Pole in 2026 as part of the Astrobotic's Griffin 1 mission. So we can see some photos they posted of the deformable wheel, and you can see at the bottom it's deformed a little bit, but it can actually deform quite a lot, so it can just easily get over small boulders and rocks. And here's another photo they posted of the wheel. Bring this one up. Actually, this is a video. This is of the larger rover called the Flex rover, and as you can see, it can carry 2 crew, or it can be autonomous. And it's great for positioning assets, scientific payloads, surveying, exploration, sampling missions. So that is the Flex rover. And I did a video on the Flex rover, so if you want to know more about it, you can just check out that video. So that is the first story this week. So let's move on to the second one. Okay, moving on to our second story on Skyrora, which is a UK space startup located in Scotland. And this story is on a new project from ESA, the European Space Agency, on 3D printing next generation rocket material called Tambium, which I've never heard of. Apparently it's a breakthrough alloy set to revolutionize rocket engine production with 3D printing. So Skyrora, it's a British rocket and space technology company, is going to be the prime contractor in this European Space Agency's General Support Technology Programme, and it's for the additive manufacturing or 3D printing of Tambium. The project aims to validate Tambium's production and performance for use in rocket engine components. It goes on to say existing aerospace alloys are limited in performance. They have various supply chain risks. This new alloy could surpass legacy aerospace materials, higher burn rate and temperature capability, 30% in weight savings in engine components, up to 95% less material waste because it's 3D printed, and the potential for a 40% reduction in total component cost. They're going to be running some 3D printing trials and validating the material and doing some mechanical testing. Skyrora has their own metal 3D printer, Skyprint 2, which is the largest hybrid 3D printer of its kind in Europe. So we have a few quotes here. This is from Skyrora saying, this is about sovereign launch capability and materials innovation. And they're saying they're heavily dependent on the US for the C-103 alloy. And our CEO of Metallysis is saying, Tambium, which is predicted to significantly enhance space component lifetimes and thermocalc solutions. Tambium represents a major advancement in high-temperature alloy technology for space propulsion. So that's interesting. We also have this X quote from Skyrora. This is talking about the same thing, Tambium. We also have a photo. This is their 3D printer. They're going to attempt to 3D print engine components, rocket components using this new alloy, and we'll see how it goes. If you're not familiar with Skyrora, I've done a video on them already, so you can check it out on the channel. There's a few photos of them testing. This is testing their second stage. This is Skyrora team based in Scotland, and this is their test site where they test out the engines, fire the engines. They actually do have a launch license. They acquired a launch license from the Civil Aviation Authority, but they can't launch until 2026 because Saxford, the Scottish spaceport, is just congested at the moment. Rocket Factory Augsburg is launching from there, so there's no capability for them to launch this year. But they have a launch license, and they will be launching their Skylark L, which is their suborbital rocket from Saxford, hopefully in the first half of 2026. And this is launched from Iceland previously, but now they can launch from Scotland, and they can launch, I think it's like 16 times a year with this suborbital vehicle. And maybe they can make some money with this and learn ground system equipment and operations and so on, and guidance systems that will all carry forward and for their, I think, Skyrora XL vehicle. Basically, they have an orbital vehicle they're working on. This is just a suborbital test vehicle. So let's move on to the third story this week. Okay, the next story we have is on Redwire Space collaborating with Starlab Space to expand commercial access to low Earth orbit. So we have a photo here. Redwire will provide critical systems for Starlab, including advanced solar arrays and life support technology, while connecting new customers and markets worldwide. The agreement includes payload capacity aboard Starlab, enabling Redwire to offer orbital research services to its global customer base. Together, we're building the infrastructure for the next generation of space-based research, manufacturing, and discovery. And if you're not familiar with Starlab, there's a render here. So this is one of the commercial space station proposals. It's received about $200 million from NASA in phase 1. Phase 2 is coming up. And I think I mentioned previously, maybe 3 to 5 SpaceX agreements. So that could include Axiom Space, Vast Space, Starlab Space, Blue Origin's Orbital Reef, and who knows, maybe SpaceX's Starship. So we'll see how it goes. It was going to transition to the FAR contracts, which are very onerous, difficult. When NASA's just decided, or the US administration has decided for NASA, to continue using SpaceX agreements, which are a lot easier, especially for startups. So we'll see what happens. We do have more information on Starlab, and this is from Daniela Besden, who was at a European user conference, actually in Berlin, and she took some notes and some photos from the slideshow. Launch is planned for 2029, orbit's 500 kilometers, inclination 45 degrees, height 17 meters, volume 387 cubic meters. That's about a third of the ISS. Powers 12 kilowatts on average, 3 ports, and crew of 8, 4 plus 4. And she goes on to make more notes. The status is high fidelity mock-up under construction, internal payload platform already built and host partner payloads, subsystem PDRs, that's a preliminary design review in progress, system level critical design review by end of 2025, that's only a few months away now, and launch vehicle is SpaceX Starship, which means single launch configuration. They launch on Starship and then it's fully deployed. Compared to the 20 years or so for International Space Station, just one launch and you've got a fully outfitted space station, which is amazing. She goes on to say orbital lab and payloads, 13 internal payload platforms, 10 mid-deck locker equivalent. That's what's used on the International Space Station. 2 external platforms, thermal control, data link, and MDA, Skymaker robotic arm. MDA Space is a Canadian company that builds the Canadian arm on the ISS. So there'll be another robotic arm, which you can actually see here. If you look here, you can see the robotic arm, and that's from MDA Space, which is a partner with Starlab. Voyager Tech Holdings, I think it's called, is the prime contractor. So that's a US company who actually owns NanoRacks. You have Airbus from Europe, you have Mitsubishi from Japan, and you have MDA Space from Canada. So that's the consortium. And I think the consortium's growing. Redwire's just become a partner, and there's some other companies as well. So it's growing, the partnership is growing. She goes on to say, Global Science Park model, first orbital science park linking terrestrial innovation centers to low Earth orbit. Partners are Voyager, Innovation Park Zurich, iPark Japan, and additional nodes under review in Germany, collaborations with NASA, ESA, JAXA, the Canadian Space Agency, and United Arab Emirates Space Agency, and partnerships and Vision Airbus, which is one of the main partners, leads European system architecture. Palantir AI powers automation and data management, 130 research slots for academic and commercial users, launch 2029, biotech, materials, and AI innovation in microgravity. So I mentioned in my video yesterday on NanoRacks, which is owned by Voyager, which is the prime contractor for Starlab, that they would be interested in space manufacturing, and that would be a key service for all commercial space stations. So it's not just pharmaceuticals, it would be ultra-pure silicon, semiconductors, and alloys. New alloys and ultra-pure alloys as well, and 3D printing of various kinds. That was going to be a key service for commercial space startups. We actually have, I took screenshots of the individual slides. So you can see the main partners here, Voyager, Airbus, Mitsubishi, MDA, and they put Palantir here as well. And basically, yeah, I can't really read the text that very well. So proven space operations and technical expertise. They've got a lot of expertise. Voyager via NanoRacks has a lot of expertise on the International Space Station. They deployed the Bishop airlock, the only commercial airlock that's actually attached to the ISS. So they have a lot of experience with doing experiments on the International Space Station. And of course, you've got MDA that built the robotic arm, the Canada arm. And you've got partnerships with ESA and so on that has habitats and modules on International Space Station. And then they talk about the current status, what they're working on here. Cygnus HTV options. So Cygnus is owned by Northrop Grumman. They do cargo transfer to the International Space Station, and they're working to be able to support Starlab. And HTV, presumably that's Japanese cargo vehicles as well. The Cygnus docking demonstration already. Launch configuration 500 kilometers, inclination 45 degrees circular orbit. And what else? We have actually cross-section of the station here. First 3 decks, decks 4, 5, 6 are stowage. Then you got crew quarters, galley, earth viewing, living areas, internal payload platforms, payload bays, orbital laboratory, system bays, exercise area, lavatory, hygiene area, and then subsystems, power distribution. And key features, 387 cubic meters pressurized volume, the mid-deck locker equivalents, modular flexible architecture, and leasable payload platform. You don't have to put modules up there, you can just lease some modules as needed, which is great. And orbital science park. Laboratories, the first science park in space. Applied research, productization, and lots of space available for equipment, experiments, and manufacturing. That's the latest slides I've seen on Starlab. That's all new information to me. I've not seen that before. Launching in 2029. We'll see whether it gets phase 2 funding. I think it's quite likely to get phase 2 funding. We have vast space with Haven 1. We have Starlab. We have Blue Origin's Orbital Reef. And we have Axiom Space. So there's quite a few space stations, commercial space stations on the horizon, as the ISS will be deorbited in 2030. Which is, getting quite close now. It's not far away. So we definitely need a replacement, and we need a cheap way to get into space and to spend a few weeks in space for research, technology development, and also for tourism. The next story is an X post by, if I bring it up, by Rocket Tesla, and he's talking about Rocket Lab and the LOXSAT mission. Rocket Lab has completed spacecraft for a cryogenic fuel mission, NASA's LOXSAT mission. So it's a technology demonstration mission that will test on-orbit cryogenic fluid management systems. That's large-scale low-Earth orbit cryogenic propellant depot. Commercial operations could begin by 2030, and he's saying it's the era of massive orbital refueling stations. Think of it as a giant space gas station floating in low Earth orbit. The key technology is zero boil-off storage. The cryogenic fuels, liquid hydrogen and liquid oxygen, boil off at very low temperatures. Therefore, all the propellants must be kept at extremely low temperatures, which is quite difficult to do from an engineering point of view. You have to use sunshades and so on. So he's going on to say reusable and operational infrastructure that can be refueled and continue operating in space. Whoever gains the ability to store and supply propellant in orbit will control the balance of power in the future space economy. NASA is planning long-duration missions such as Artemis, Mars sample return, and human landings on Mars. Such missions are impossible if all the required fuel must be carried from Earth. LOXSAT has already achieved technology readiness level 5 or 6 on Earth. These awards, this is according to NASA, these awards will enable technologies that support a sustainable lunar economy and future missions to Mars by creating commercial services such as refueling depots, power operations, and in-space resource utilization. NASA has already recognized this technology as a turning point that will reshape the paradigm of the space economy. And he goes on to say Rocket Lab is well positioned to perform repeat launches, spacecraft manufacturing and operational services, and that Rocket Lab is evolving beyond a simple launch company. And the technology itself may seem complex, but the direction is crystal clear. The era of refueling, reusing, and operating directly in space has begun. I found that interesting because there's quite a few companies now working on storing cryogenic propellants in space. Blue Origin with their cislunar transporter are working on exactly the same technology. And I covered a space startup a few weeks ago. I think it's Orbital Operations or something. That's also working on cryogenic storage of liquid hydrogen and liquid oxygen in space. So I think we are moving slowly, or maybe not that slowly, into storage of large amounts of cryogens in low Earth orbit. Will support the cislunar economy, making it a lot easier to refuel and to travel further and to do more in space, do more operations, move around a lot easier, which will be fantastic. Okay, on to our final story this week is on a brand new company called Mersenne Tech, which I didn't know anything about until a few hours ago. This just popped up, so let's have a look at this. I put myself in the corner. So this guy, Kevin Segnicki, I think he's a co-founder or founder of Mersenne Tech, and he just wrote a Twitter thread on the company introducing Mersenne, an attempt to build one of the most important missing products for the 21st century. And he's talking about building a key piece of technology for the rapid expansion of civilization in space. Ultra-compact power boxes that can generate energy for years without refueling. We want to power billions of humans on Earth, in orbit and beyond. Endless atomic power anywhere and at any time. SpaceX does the rockets for Mars. We want to do the energy. Here's one of their power systems. This is for the Earth. It's a terrestrial system called Starfall. He goes on to say, our final vision is to lead humanity up the Kardashev scale and into the stars. We aim to build power systems for human settlement on the Moon, Mars and beyond. We want power stations in orbit and for deep space mining. These are all the basic building blocks for 1 billion humans living in space. We do have the website. I had a look at the website. There's not a lot of information there, but we can have a look at what it says. So this is the website, Mersenne Tech, powering the final frontier. So they talk about becoming a multiplanetary species. Humanity needs compact, long-duration, off-grid power. Nanoscale atomic energy is the solution. No other form of power can endure the 354-hour lunar night, generate rocket fuel on the Martian surface, or power mining in the asteroid belt, far beyond the range of solar or batteries. So they aim to demonstrate that atomic energy can be generated in a form factor small enough to deploy anywhere. So first they're going to start off with Starfall, which is a terrestrial reactor, which is 40 kilowatts, but they can scale it up. So here's their initial product called Starfall, 40 kilowatts of power, and it's for commercial terrestrial use. But they go on to say, let's scroll down a bit more. They go on to talk about space. Yes, here they're talking about off-world. They say atomic power enables long-duration expeditions and permanent installations beyond Earth. It is the only infrastructure for making human life possible in the final frontier. So that's all we know, but I thought it was interesting. A brand new company focused on power systems, off-grid power systems for the Moon, Mars, and beyond, starting with 40 kilowatts and hopefully going to more output over time. So that's definitely interesting. So that's all I wanted to talk about this week. If you like this format, please subscribe to the channel. I do 4 videos a week, 2 on dedicated subjects, and then I do a midweek space news roundup, and then I do a live stream at the weekend where I just talk, recap my videos that week, and bring up comments people have left over the week on the videos and chat messages. So thank you for joining, and see you next time.